Hello students, in previous class we have solved the exercise questions up to the question number 12 we have solved. Now today we will see the question number 13. Now question number 13, we have a hot plate of an electric oven connected to a 220 volt line has two resistance coil, each of 24 ohm resistance, which may be used separately in series or in parallel. What are the currents in the three cases? So here we have two coils A and B, each of resistance is 24 ohm. Now these two resistors are connected series or in parallel, right, or separately, right? So here what are the current flowing through each cases we have to calculate. So let I take first one, that first one case, when the coils A and B are used separately. Okay, now what is the data here? Resistance is 24, voltage is it's 220 volt, correct? Voltage is 220 volt. Now by Ohm's law we have V is equal to I into R. Therefore, I is equal to V by R. Right. Now this is equal to, what is the voltage? It is 220 volt. Resistance, it is 24. Resistance of the coil is, that is 24 ohm. Now divide this one. 4 6 are 24, right? 4 5 are 20. 4 5 are 20, right? Now you just divide this one separately. We have 55 divided by, that is 6. Now 6 9s are 54, right? Okay, now take 1 0. 6 1s are 6. It is subtract, you will get 4. Now 6 6 are 36. Okay, now we got, after point we got 2 digits, so let I take the answer. That is, the current is 9.16 ampere. The current is 9.16 ampere. That is, when we use the coils separately, the current flowing through each resistor is 9.16 ampere. Now when two coils are connected in series. Second case, when the coils A and B are in series. Resistance is 24 plus 24. This is equal to 48, and voltage is 220 volt. Right? Now current is equal to, that is according to the Ohm's law, current is equal to, it is V divided by R. This is equal to, V is how much? It is 220. R is how much? It is 48. R is how much? It is 48. Now 4 1s are 4. 4 2s are 8. 4 5s are, it is 20. 4 5s are 20, right? Now take it separately for easy simplification. 55, 12. Now 12, how much it is 55? 12, 4 it is 48, right? Subtract this one, you will get 7, this is 0, so take one 0, right? Now 12, how much the 70? 12, 5 it is 60, 0 and 1. Now take one more 0, it is 100. 12, how much the 100? 12, 8 it is 96. Okay, now we got after point we got 2 digits, so no need to be simplified further. So here current is 4.58 ampere. Current is 4.58 ampere. That is when two coils are connected in series, the current is 4.58 ampere. Now let's go to the third case. Okay, now third case, when the coils A and B are connected in parallel. Case number 3. That is when two coils A and B in parallel, right? Now two coils are connected in parallel. The resistance, the equivalent resistance is, that is R1 into R2 divided by R1 plus R2. R1 is 24, R2 also 24 divided by 24 plus 24. Okay, now 24 into 24 as it is, add these two, it is 48. Okay, now 4 1s are 4, 4 2s are 8, right? Now 4 6 are 24. Now it is 12 1s are 12, 12 2s are 24, right? Now 6 into 2, it is 12 ohm. So the equivalent resistance we got 12 ohm. Now what is the voltage? The voltage is 220. Therefore current is equal to V divided by we have to take R. This is equal to V is how much? It is 220. Now what is the resistance? Resistance we got, it is 12, right? Now how to divide this one? Now 4 3s are 12, right? 4 5s are 20. Now 4 5s are 20, right? Now let I take this one separately. Now 55 divided by 3. 3 1s are 3. Subtract this one, you will get 2 and this 5 as it is. 3 8s are 24, right? You will get here 1. Now take 1 0, it is 10, right? 3 3s are, that is 9. So you will get 3. So 3 3 it will come like this only. So here the current is 18.33 ampere, which means when the coils A and B are connected in parallel, what is the current is flowing? That is the current is flowing 18.33. Similarly, when the coils are connected in series, the current is flowing 4.58 58 ampere. So hence we have solved the problem. The next question, question number 14. Compare the power used in the 2 ohm resistor in each of the following circuits. So first one, we have a 6 volt battery in series with the 1 ohm and 2 ohm resistor, and second one we have a 4 volt battery in parallel with the 12 ohm resistor and 2 ohm resistors. Okay, so this is the question. Now look at here, we have to compare the powers. We have to compare the powers used in 2 ohm resistors, and the circuits they have given. First one is 6 volt battery in series with 1 ohm resistor and 2 ohm resistor. Let I show you with the diagram. So solution, first one, that is we have 2 resistors. One is 1 ohm and another one is 2 ohm. The resistor 1 ohm and the 2 ohm connected in series. So these two resistors are connected in series with the battery 6 volt. With the battery, that is 6 volt. Okay. Let's suppose that current I is flowing in the circuit. So this is the first situation. So here I need to calculate power used in 2 ohm resistor. Power used in 2 ohm resistor. Okay, now what is the given data here? Given data is what? That is, we have R1 is 1 ohm, whereas R2 is 2 ohm, right? Now as these two are connected in series, what will be the total resistance? That is, total resistance RS is equal to R1 plus R2 is equal to 1 plus 2 is equal to 3 ohm, right? Now they have given the battery is 6 volt. This battery is 6 volt. Therefore, potential difference is 6 volt. So what we need to calculate here? We need to calculate the power used in 2 ohm resistor. Power used in 2 ohm resistor. This is equal to, we know that the power formula, that is power is equal to I square into R. We know that the power is equal to I square into R. We know the total resistance in the circuit, but we don't know the current. So first we need to calculate the current. This implies that by Ohm's law, we know that by Ohm's law, we have, that is V is equal to I into R. Therefore, I is equal to V divided by R, right? Okay, now put the value. I is equal to, V is how much? V is 6 volt. V is 6 volt. Total resistance in the circuit, we have 3 ohm. So 3 ones are 3 twos are. Therefore, I is equal to 2 ampere. I is equal to 2 ampere. So the current flowing in the circuit is 2 ampere. Now here we know current and we know the resistance. So we can easily calculate the power used in 2 ohm resistor. Okay. This implies that P is equal to, that is I square into R. This is equal to, I is how much? It is 2. This square as it is into R is how much? That is, we need to calculate the power through, that is 2 ohm. So I have to take resistance 2 ohm. This is equal to 2 square is 4. This 2 as it is. This is 4 to the 8 watt. So the power used in 2 ohm resistor is 8 watt. Okay. Now we have one more part, that is second one, a 4 volt battery in parallel with 12 ohm and 2 ohm resistor. Second one case, we have two resistors, 12 ohm and 2 ohm. Two resistors, one is 12 ohm and another one is, we have 2 ohm. Okay, now here you just look at here, they have mentioned that it should be connected in parallel. Okay, it should be connected in parallel. So I need to take this one in parallel. So this is the parallel connection of two resistors, and these two are connected to the battery, which is having the potential difference, how much? 4 volt. Potential difference is 4 volt. Now here we need to calculate the power through 2 ohm resistor. So here, what is the given data here? They have given potential difference is 4 volt, right? And here there is R1 is 12 ohm and R2 is 2 ohm. Okay, now calculate the power. Calculate the power. Look at here. Here, as in the previous one, I have calculated the current. And after that I have calculated for the power. But in this one situation, you can directly calculate the power by using the formula. That is, we have the formula, that is power is equal to V square divided by R. You can calculate using this one formula directly. This is equal to V is how much? It is 4 square as it is. R stands for the resistance, that is we have to calculate, that is 2 ohm resistor. This one resistor, not this one. So 2 ohm resistor. This is equal to 4 square is 16 divided by 2. 2 ones are 2 8s are. Therefore power is equal to 8 watt. Therefore the power is equal to 8 watt. So here in both the circuits, that is the power used by the 2 ohm resistor is same, that is 8 watt. So hence we have solved the problem. The next question, question number 15. Two lamps, one rated 100 watt at 220 volt and the other 60 watt at 220 volt are connected in parallel to electric main supply. What is the what current is drawn from the line if the supply voltage is 220 volt? So here in the question we have two lamps. Okay, we have two lamps and both the two lamps, one is rated with 100 watt and another is rated with the 60 watt. Okay, and they are connected in parallel, and we need to connect the current drawn from the line if the voltage is 220 volt. So the given data is power of first lamp, it is 100 watt, and power of second lamp, it is 60 watt, right? And the voltage is 220 volt, and the voltage is 220 volt, and we need to connect, we need to calculate the current. We have to calculate the current when these two lamps are connected in parallel, right? So here we know that the relation power is equal to voltage into current. We know the relation Power is equal to voltage into current. Here voltage we know, power we have the power P1 and P2. You just add these two, calculate the total power, and voltage we know, and easily you can calculate the current. So here total power in the circuit, P is equal to P1 plus P2, right? This is equal to P1 is 100 watt, P2 is 60 watt. Add these two, it is 160 watt. So the total power in the circuit is 160 watt. Now you can easily calculate the current. This implies that P is equal to voltage into current. Therefore I is equal to, I can write P divided by V. Okay, now this is equal to power, how much it is? 160 divided by voltage. What is the voltage? 220. 0 0, both are get cancels together. 2 1s are 2 1s are 2 8s are. This is equal to 8 divided by 11. Simplify this one. 8 should be divided with the 11. So take 1 0, it is 80, and here 11 7s are 77. Subtract this one, it is 3. Take one more 0, it is 30. 11 2s are 22. So it is 8. Take one more 0, again it is 80, and 11 7s are 77. So like this the number it will come. So we got the current is 0.727. okay, 0.727 ampere. So the current drawn by the two lamps when they are connected in parallel is 0.727 ampere. So hence we have solved the problem.